Moving target defense for resilient cloud management. Project outline. Team members' contributions. Core logic of the project. System model. Attack detection, and finally, virtual machine migration. Team members and their contributions. Moving target defense for DDoS attack. This represents the core logic of our project. So moving target defense is the concept of adaptations across multiple system dimensions by moving around the target applications. Moving target defense focuses on enabling safe operation in a compromised environment rather than trying to create a perfectly secure environment. Here we have our application running on a virtual machine. We have a legitimate user that can access and enjoy this application or service. Now the attacker appears and starts attacking the virtual machine that hosting the target application. We have candidate VMs that can host this compromised application. Now the controller migrates the virtual machine that hosts the application to another virtual machine and start the service from there. And the attacker is left on the decoy VM. System model. This is the logical network architecture of our system. This model shows type of the network components regardless the number of components from each type. The main components in our system, we have the virtual machine that hosting our application. We have an open flow controller that represents the data plan, the control plan for our system. We have attackers, regular client, and candidate VMs. Physical network architecture, we have number of attackers and number of legitimate user. We have controller, open flow switch, and candidate VMs. Attack model. In this project, we have implemented a chaos monkey attack model, which we can call it also a multi-vector model, which make our system different from the previous implementation of this project, where we can launch the attack using different attack tools against different layers of the target server. So we use more attackers, different attack tools, and we attacking different layers at the target server so that we can crash the server as soon as possible. And the detection part of this attack and the defense part is much harder. We use TCP sync using HB ping 3 tool. This is the normal TCP connection. And this is TCP sync flood, which we are using against layer 4 at the target server. Application layer attack, we are using HTTP GET attack, which is attack against layer 7. Where the attacker looks like legitimate connection, and we also using GoldenEye to implement this attack. We also using Slowloress as an application layer attack. This attack exploit the blocking nature for Apache server. It does really win the race by moving slowly and steadily, and it does not consume network bandwidth, so it is very good for GENI infrastructure and it will not be affected. This is the technique used by Slowloress to launch and the attack and crash the server. There is some statistics about the attack performance. that shows the number of the connected user to the server against the time in seconds. So as you can see that after 100 seconds, the server crashes and we cannot get the service.
Okay, hi. So now we'll be talking about how the test bed and the entire setup is for testing our application and the concepts. So what we just viewed was the actual topology, the physical topology, which is real life scenario. But what we tested is a much scaled down version of it, which you can see here. It's got a user, attacker, an open flow switch, a controller, and a couple of servers, which could be source or candidate destination servers. By candidate destination server, I mean that when you migrate something over from the server, these are the possible VMs which you can select, and based on something, which we will discuss later, you send it over to some server X, and then the service has to resume from server X. Okay, so now I will hand it over to Josh to just talk about the UI.
Alright, so here we have our glorious looking UI with a special little video with our best friend John Oliver and his beautiful parrot-shaped mug that you can see going on right there. So the way this works with our servers to help with migration is whenever the video is paused, it will store its timestamp in a TXT file, which it reads upon being reloaded and automatically applies it to the time of the current video. So the video should resume from the current time as demonstrated here.
You've learned exactly one thing.
Like that.
The midterm.
And every second or so, it scans the directory that it is in for the trigger file, which is just something along the lines of attack.txt or attack.txt. When it detects it, it automatically stops the video, records its timestamp, and then waits for the migration.
Alright, so now we'll try to crash the server. Our aim being to just show how DDoS works. So once the DDoS attack starts, the server should crash and the service should get interrupted. So let's check it out.
I'll show you guys how we launch the attack against our target application. Here is the target application on the virtual machine, and here is the attacker that will crash the server using this script file. I will start getting the web page and start launching the attack.
If you've been near a television recently, you've learned exactly one thing. The midterm elections.
You will see that this video is stopping now, and our attack is successful in crashing the server that hosting the target application. The next step, we need to detect this attack and issue or generate triggers to the controller to migrate the virtual machine to another good candidate machine. Before that, I will show you how we can stop the attack and the video can resume from the same point. Now the attack is stopped. And you can see that the video
to go before the midterm elections,
is resumed from the same point with very high quality.
Do the Democrats hold on to the majority?
Can Republicans take control of the U.S.?
Alright, so now we just brought the server to its knees. And we just spoke about migration. Now, here's the thing. Just simply migrating is not enough, because we have to first figure out which destination server might be best, or it will offer some resources which might cater to the requirements of this specific application or service. Now, if we migrate over to a bad server, let's say for instance, like we showed in the topology before, we have server 1, 2, 3. Now, let's say server 1 is being attacked, server 2 is probably free, and we can send the stuff from server 1 to server 2. But instead, we just randomly pick server 2 and 3 and we send it to server 3. Now here's the thing, maybe server 3 is down, maybe it doesn't have enough resources, maybe it's being attacked. So let's see what happens if we just randomly migrate the files over to a different server and see how it works. Now in this case, we are not using any smart algorithm. and we are just bluntly picking random destination server. So let's check it out.
As you can see, here we have two bash scripts to attack different server. The attack file will attack server 1 and the attack 2 will attack server 3. We start by attacking server 3 to crash this server. I'll start the attack against server 3. And I will get the service from server 1.
American history. Oh, but I'm serious this time.
As you
Take
can
your
see,
American history books.
The service quality is very good
Why
and the
Senate
video
is up for grabs,
goes
and the
nicely. Now
people's
I will launch the attack
Senate is
against
up for
server 1
grabs.
to crash this server.
All this
I start the
crazy
attack
talk
against
of
server 1.
congressional races is a little strange
You will see the
around
effect
important
of the
things.
attack on this server within
with
seconds.
Republicans in charge of the House and Democrats in charge of the Senate, is on track to...
As you can see, the service is stopped at server 1 and we cannot get any more data or service from this server. Now I will move to the server to the server 3, which already attacked. As you can see, we cannot get any service or any video from this server, although the migration is done to this server, but we cannot get the service.
Okay, so now that we have seen what the problem with the current solutions is, or not rather solutions, it's just a few of the ways in which reactive defense against DDoS works. Everything we are doing is reactive, it's not proactive, since so in case of proactive, what happens is you take measures beforehand just in case of attack, something happen, what to do. But what reactive does is, in case, not just in case, when the attack happens, before things go down, you take measures to make sure that service runs smoothly, completely smoothly. And so that's what we're trying to ensure. So what next we do is we'll show what we have done. Now in the previous example, you saw that when we instead of smartly deciding what destination server to send to, you just randomly pick a server and send it. It does not always work well. Now this is especially bad for multi-million companies or corporations who have to rely a lot on user satisfaction. If anything goes down for even a few seconds, it could cost them millions of dollars. That is bad. So what we do is we smartly decide which server will give you the best performance among the available ones, and we send over the migration. The migration basically happens from the source server to this picked destination server. We have a couple of scripts which I'll be explaining in a minute. So now I would like to hand over video control to Samah here. She'll be explaining how the detection and trigger happen. The detection and trigger are basically what will happen when the attack has been detected. So
Okay. I'll show you the logic behind the attack detection. Now we are on server 1 and we have two script files. The first one is called attack detect, which detects the number of IP address connected to the server. This can be considered as a measurement tool, which is a background daemon also that runs every 1 second at the target server and captures the IPs that have active connections with the server and counts the number of active connections from each IP address. Then we have the second script file that run the first script file periodically, let's say every 1 second, and copy this text file which contains the IP of the attackers through a secure channel to the controller. Now this text file is a trigger to the controller to issue a migration command.
Hi, now I will be showing the migration scripts that we used to move the target application from where it was running, that is the server that had just been attacked, to a new destination, to a new server, so that the user can start from where he left off. So we have some codes that we did in Bash and Python, which you can see. These are the files. Like we have about 5 to 6 of them. Let me talk about the first step we do. We locate all the VMs, all the URL to the VMs, to the servers in a text file that, as you can see here, is candidate VMs.txt. Let me quickly go into that and check. txt. So here what we do is we have three servers. As you can see, we have three servers, 1, 2 and 3. So this thing actually is the resource utilization of this particular VM. This one is resource utilization of this, and this one is of that. So we check this as one of the conditions, one of the constraints to get the best or the ideal VM. Whereas this here is the reputation of the server. The reputation of the server depends upon how many times it has been attacked, and then actually it depends upon the attack. How good the particular VM is. So let me quickly get back to see what we do. So we use an algorithm to select from this pool of VMs, which is actually algo.py. So this is the code where we get in the destination file and then select the better virtual machine. And then once this is done, we have a script that's called migration trigger, which we use to set the variables of a source virtual machine and the destination virtual machine so that the controller can start execution. So this here, the migration triggers, the py, is the script that sets the variable to source and destination, which then passes it to controller execute, where we do the actual copying or the migration of the application. So let me go through controller execute. Here, as you can see, what we do is we compress the target application, which is there in the source, and then we send it to the destination. And as soon as it reaches the destination, what we need to do is that since everything has been compressed, we need to uncompress it or decompress it at the destination. After doing that, we install the target application in that destination virtual machine. This is how we have done the migration part. As you can see here, the compress and send is the bash script that the controller execute calls to compress and send the application, and here is uncompress and install, which actually does the uncompressing part and installing the application to the new VM. We have tried various types of things during the migration, or like for the migration, which include migrating the VM itself, and along with that migrating only the application. So since this would be like very quick, and also the user should not be able to figure out, like even if he figures out, the service should be like restarted or like started from where it was stopped as soon as possible. So when we sent a snapshot, we actually found out that a snapshot which has the application is of about 600 plus MB in size. So when we copy that, we actually happen to take a lot of time. So to cut this down, what we thought is that why don't we just send the application and do it? And that is where we got the trick. So that's how we actually were able to migrate, run the service, and start from where it stopped within 10 seconds. Thank you.
Alright, so now we are going to be showing you what we have done and how it comes into play. So in this phase, what we'll do is we have the server files on server 1, and the user is trying to access the video or any application which is hosted on server 1. Now, if let's say an attacker starts attacking on server 1 using DDoS, then in that case, a couple of reactive things happen. First is the controller finds out that there's been an attack, and it starts calculating which server would be the best destination for this application slash service or whatever. Now, once it finds out that best destination, it sends a command to server 1 to package itself up. It sends over the entire server configuration as well as server files over, server applications and files over to server X, which is being picked by the scripts at the controller. And this entire thing is migrated over, and once you go to the other server, you'll see that the service just resumes from that point onwards. So let's test it out. Okay, so now I have the topology here: server 1, server 2, server 3, controller, user, attacker, the switch. And let's try and access the user from here. So now this we will be trying to access the contents of server 1, and I'm the user here. So when I launch this website, it'll access server 1 contents and the video will start streaming. The next thing I'll do is I'll start an attack, and the controller will be listening for an attack, and the next phase would be, well, let's check it out. So we have the video playing.
Television recently, you've learned exactly one thing. The midterm elections are upon us. 2 days to go before the midterm elections.
Some super interesting stuff here. Okay, and let's check out the attack part. We have the attacker, we have the controller, and we have server 1. So the server is now constantly sending its status over. And the attacker, let's say, has started attacking. Before I do that, our controller has to be listening for an attacks. So what we do is we need to make sure that the candidate VM text file contains the information that it requires. So let's look at it. It has its CPU utilization and repeatability factors all present. So based on this, it'll decide which server to send it over to. Let's say the best server is not server 2, server 3, but server 2, which is the first one here. So I'll change the values. The reason I'm doing it is this will eventually be automated. So what happens is if a server is attacked, then in that case its reputation goes down, and once the reputation goes down, it gets updated in the text file or database, and the new values are used for next calculation next time, because every time a server gets attacked, its reputation should go down. And similarly, in a periodic manner, we keep checking the CPU utilization or other resource utilization factors and keep them in check. So based on those, we decide what destination to pick. So let's say the reputation is really high, the CPU utilization is good amount here. So the resource utilization here is not directly related to the numbers you see. The higher number here is better. All right. So we should be sending, so the script should actually now calculate that PCVM79, the other server, should be the best destination, the server 2. All right, let's launch an attack after listening to the controller. We are listening for attacks. The video is still streaming, and we attack. Service still available. Let's see. And before the server even goes down, just a split second before it, we see that the migration has kicked in. As you can see here at the controller side, it has decided on the best source well, sorry, the best destination, because the source is still any whichever source it's coming from. The destination has been decided to be PCVM79. It has migrated over everything, the contents, all of it, the server files. And once it's done, we should be able to stream from the position that it stopped at. So let's test it out. The attack is still happening. So here's the primary part to notice. The attack is still going on at server 1. Service unavailable at server 1. Now let's check this out. We resume from the original position when the server 1 is still under attack.
Get worse.
A Florida
So
lawmaker is
that's
pushing
it. We
forward
decide
tonight
the
with
best
his
destination.
plan
We
to
migrate
repeal
the
a
stuff
ban
over,
on
and the
dwarf
service
tossing.
resumes from the point onwards where it was actually paused or stopped for migration.
They said no, you can't.
So
we'll make it for you.
thank you guys. Hope you like the project.
Individual
Thank you.
rights aside.